Hello! In this session, I'm going to continue with angles and I'm going to talk about some simple relations between angles on different parts of a figure. Let's start with angles on a straight line. Now, suppose that I have a straight line like that, and from a point in the middle, I have another line. You can see that there are two angles here and here, right? Now, if you have two angles like that, then one important thing to know is that the sum of these two angles is 180 degrees. Now we know that because we know that the angle on a straight line is 180 degrees, as we have seen in the last session. So we describe this result by saying that let's see, I'm missing a word there. Right, we describe this property by saying that the total angles on a straight line is 180 degrees. Now, how can we use such a result? As a simple example, you might see a question that asks you, or that tells you that this angle is 40 degrees and asks you to find that angle, which I call x. So you might see this question with this figure in a paper. So the question is that if you have this angle as is 45 degrees, what is x? And you can find the answer if you know this property, that the total angles on a straight line is 180 degrees. The reason is that then you know that x plus 40 degrees must be 180. So once you know that, x must clearly be 180 minus 40. Okay, so let me start by writing this property. It is saying that x plus 40 degrees has to be 180. So you have an algebraic equation, and you can use algebra to find x. But because this is quite simple, we don't really need to think about algebra, because all we need to do is, we know that these two, the sum of those two angles is 180. So if you take 180 minus 40, you must get x. So therefore, x is 180 minus 40. And the answer is 140 degrees. So this is one example. Alright, so this kind of result that tells us the relation between two or more angles is called a property. So this is a property of angles that we are learning. Let's look at another example. Suppose I have two lines crossing each other. You can see that in this figure there are 1, 2, 3, 4 angles. Now I'm going to look at just two of them, one there and one there. Now you can guess that these two angles should be equal. Okay, they look equal, they look symmetrical. So in fact they are. We describe this property by saying that they are vertically opposite angles, and that vertically opposite angles are equal. Okay. As an example, you might see this question in an exam paper. The question which says, suppose that this is 30 degrees and this angle is y. Find y. So if you know this property, you know that vertically opposite angles are equal. That means the angles like that on opposite sides of two intersecting lines, you know that these two angles must be equal. Therefore, y must be 30 degrees. So you have the answer. Now, one point to note is that unless it is a multiple choice question, you often have to give some explanation in your working. So if you write down y equals to 30 degrees in your question, it would always be good to say that y equals to 30 degrees because they are vertically opposite angles. Okay, or you can just maybe put a bracket or just write down here next to the answer, vertically opposite angles, and that will tell the person, your examiner, who has to mark your answer, that this is the explanation, and that you understand why this is the answer. Okay, and it can also be part of your working, and you might get marks for that. Another type of angles that we look at now is angles that involves two parallel lines. So suppose these two lines are parallel. That means that they go along the same direction forever. No matter how far you go, they will never meet. They will just keep going and going and going. So these are parallel lines. Alright, and we often show that they are parallel lines by putting a little arrow on each line. So if you have the same arrow on each line, then it's a symbol. Right, the little arrows here is used as a symbol to tell us that the two lines are parallel. Okay, we don't have any angle here so far. Now let me draw a line across them. So this line cuts through the two parallel lines. Now once you do this, you see that there are many angles down there. And in fact, we have three properties coming from this figure. Okay, let's start from this angle and this angle. Now, these two angles are on opposite sides of the line, this slanted line, and these two angles, they are actually equal. Now you can see that it looks likely that they are equal because this shape is symmetrical. If you imagine flipping this shape around, this angle would just flip into this angle. Alright, the bottom part looks exactly the same as the top part. Right, or if you just rotate this by 180 degrees, it would just look the same again. This angle will come down here, that angle goes up there. So because it's symmetrical, these two angles are equal. Alright, now there is a name for this pair of angles. It's called alternate angles. So alternate angles are equal. So once again, you might see a question in your exam that looks like this. Suppose that this angle is 60 degrees and that is x. Find x. So if you know that alternate angles are equal, then you know the answer, that x must be 60 degrees. Okay, we have our answer. X is equal to 60 degrees. And once again, if you are writing this down as your answer, it would be useful to put down alternate angles next to the answer or in your working, and that is the reason. Alright, that is the reason that you give for why x is equal to 60 degrees. So that's alternate angles. So that's one property. Okay, I've said that there are three properties. So what is the other property? Let me just draw this out again quickly. Two parallel lines, one line crossing through it. Right, so this time I'm going to look at this angle and this angle. Okay, so this time they are on the same side of the slanted line. Now, and they are called corresponding angles. Okay, these are called corresponding angles, and the property is that corresponding angles are equal. Now once again, you can roughly see why they should be equal, because this line is parallel to this. So if you imagine shifting this line downwards, okay, this line is fixed. If you imagine shifting this line from there to there, it is a kind of a symmetrical translation. So this angle and this angle will just look the same. If you shift this line downwards, this angle will shift until it fits exactly into the lower angle. So corresponding angles are equal. So for example, if this angle is 120 degrees, and in the exam you need to find y, you need to find that angle there. So the answer is y is equal to 120 degrees. And the reason is they are corresponding angles. So in your working you can write y equals to 120 degrees, and next to this answer you can write down corresponding angles. So that's two properties. Okay, there is one more. Let me clean that. Okay. So the next property involves one angle there and one angle there. So these are on the same side on the same side of the slanted line, and they are sort of on the inside of these two parallel lines, on the inside part. So there is a property for those two angles. The property is that the sum of these two angles is equal to 180 degrees. Now we can understand why if we remember that those two angles are equal. Okay? If I have an angle here, this angle is also equal to x. I call that x. Because they are alternate angles, that was the first property just now. Because this is equal to x, we know that this plus this must be 180. So therefore, that plus that is also 180 degrees. Okay, so these two angles are called supplementary angles. Okay, we actually describe them by calling them interior angles, and the word supplementary means that they add up to 180 degrees. So let me say, supposing, for example, if you have a question like this in the exam, where this is 110 degrees, and the question is to find x. Let me clean that up. So that they are supplementary angles means x plus 110 degrees is 180 degrees. Okay, supplementary means that they add up to 180 degrees, and therefore you can find x. X must be 180 minus 110. That's 70 degrees. Supplementary angles. Alright, let's now look at triangles. So you would probably know what a triangle is already. A triangle is a figure with 3 sides, with 3 straight lines as a side. Okay, and the 3 lines all joined together to make this figure. So first, we will quickly look at the different shapes that a triangle can take, roughly. So we often see a triangle that looks like that. Now, a triangle can also look like that. That's also a triangle. The difference between these two is that in the first triangle, all the angles are less than 90 degrees. They are all acute angles. Whereas in this one of the angles is more than 90 degrees. So it's an obtuse angle. So because of this, we think of them as different types of triangle, and we call the first one an acute angled triangle. We call that acute angled. So we have a D at the end of that to turn the angle into an adjective. So this is an acute angled triangle. Okay. Now that, because of this obtuse angle, this angle that is more than 90 degrees, we call it an obtuse angled triangle. Now there is one more angle which is quite special, which we are going to see quite a lot. It is this triangle in which one of the angles is 90 degrees. So that's how I represent a 90-degree angle with a little square there. So this 90-degree angle is also called right angle, as we have learned. Okay. So we call this a right-angled triangle. Right-angled triangle. So notice the correct spelling. I have a D at the end of angle. Right? So it's like the past tense, but in this case, making it past tense turns the word angle into an adjective, right? Into a word that describes the type of triangle. So we have looked at 3 different types of triangle by looking at the size of the angles. Okay, now I'm going to show you another 3 types of triangle in which we look at the lengths of the sides. So it's just another way of looking at the shapes of triangles. So let us start with a triangle in which all the sides are equal. Now, we can draw little short lines across each side to show that all the sides with these short lines, have equal length. Okay, so if I draw a triangle like that with the little marks there, it means that this side equals to that side equals to that side. So this is a type of triangle where all the sides are equal, and there is a name for that. We call that an equilateral triangle. Now there is something special about an equilateral triangle that I will explain more about why later on, but I'm just going to say that in an equilateral triangle, all the angles are equal. Okay, we can understand that because if all the sides are equal, then each angle will look symmetrical to the other. So therefore, they're all equal. But also, each angle is exactly 60 degrees. So that one is 60 degrees, that one is 60 degrees, and that one is also 60 degrees. So I'll explain more about why later on. Now I'm going on to look at the next type of triangle. This is the type where only two of the sides are equal. So the remaining side could have a different length. Okay, that might be shorter or longer than that. Now this kind of triangle where two of the sides are equal is called an isosceles triangle. So that's how you spell it. Isosceles. Alright. Now there is also a property about the angle, which is that those two angles are equal. And you can see why, because since these two sides are equal, so this side is symmetrical with that side. And because of this symmetry, therefore these two angles must be equal. So this side is like a mirror image of that side. It's like it's reflected from there to there. If you imagine a mirror down along a line down the center. So that's isosceles triangle, and there's one last triangle that I'm going to show. This is a triangle where all the sides are different. Okay, so that's the shortest, that's the longest, that is in between. All the sides are different, and we call this a scalene triangle. Scalene is spelled S-C-A-L-E-N-E. Scalene triangle. So all sides are different. Next, we'll look at some properties of the angles of a triangle. Let's look at the first property. So the first and most important property for the angles in a triangle is that when you add up all three angles, the answer is always 180 degrees. Let me call that angle A, B and C. Alright, I have three angles there. If I add up all three angles, A plus B plus C, the answer is always 180 degrees. Now, always means always. It means that if I have another triangle with different sides, which has different lengths on the sides, then if I add up the angles of that triangle, the answer must also be 180 degrees. So it means that when you add them up, no matter what the shape of the triangle is, no matter how big it is, no matter what type of triangle it is, okay, the three angles must always add to 180 degrees. So how can we use this? Let's look at an example. Suppose we have a question which says that this angle is 50 degrees and that angle is 70 degrees. So what is x? Okay, so 50 degrees, 70 degrees, what is x? That's the question. So, in order to do this question, you must know the property, this property, that the sum of the angles in a triangle is 180 degrees. That means that if you add up all three angles, the answer must be 180 degrees. So let's write that down. We have 70 plus 50 plus x must be 180 degrees. So once you write this down, you can see that we can use, it is an equation, and we can use algebra. We can use the methods in algebra to find the answer. Or we can also think this is quite a simple problem. We don't really have to think about algebra actually. If you just look at this figure and you see that, right, when you add up all three numbers, you should get 180. So therefore, if you know that two of them are 50 and 70, what is the last one? And it's just simple arithmetic. You can just find the unknown angle by taking 180 degrees and subtracting that angle and that angle. Okay, so that would also be simpler. Therefore, x is just 180 minus 50 and minus 70. And that, the answer would be 60 degrees. So we can do this question if you know that the sum of angles in a triangle is 180 degrees. Now next, we are going to look at the next property, which is also very important. Okay, we have a triangle. I'm going to call it A, B, and C. Now, what I'll do now is that I'll choose one of the sides. Let's say I choose AC, choose this bottom side, and I'm going to make it longer. I don't mean make the side longer, I mean to draw a line along this line so that it comes out. Now there is a word which is used to describe this extended line in mathematics. If the side is the side is called AC, okay, then this extended bit is called AC produced. It's a rather odd use of the word produce, but it simply means that from AC you draw a straight line that goes beyond AC. Okay, so that's what AC produce mean, if you ever see it in a book or in your exam. Right, so AC produce, okay. Now, this property is about that angle. So you take one side, you produce it, okay, and you look at the angle that this extended, this line that is sticking out makes with the other side of the triangle. So the property has to do with this, and the property is that this angle is equal to the sum of those two angles. In other words, this angle is equal to A plus B. Okay. Now if you are seeing this for the first time, it might look rather strange. Okay, so how are we going to use this? Well, it will happen in quite a lot of questions. We'll come on to those. But for now, let's just get a rough understanding about why you can get this by adding those two angles. So A plus B means this angle plus that angle. So in other words, when you add those two angles, you get that angle. Why? Okay, it's because of the first property. Now, you remember that the sum of the three angles in the triangle is 180 degrees, right? So if I add angles A, B and C together, the answer must be 180 degrees. Remember that? Okay, let me write that down on the side. So angle A plus B plus C must be 180 degrees. That was the property that we saw just now. Now that angle is the angle C. This is the angle C. Alright, that's what we mean when we say the angle C is that one. So we have this property. Now look at this angle C and that angle. If this angle is A plus B, then the total angle on this straight line is A plus B plus C. And we know that A plus B plus C is 180 degrees. So therefore it makes sense. Alright, it makes sense that this angle should also be A plus B. Because we know that A plus B plus C is 180 and that the angle of the straight line is also 180. So that's the connection between the two. Right, so we need to learn some terms for this. That angle is called the exterior angle. Okay, and those two angles also have a name. They are called the interior opposite angles. Okay, interior because they are inside the triangle. Opposite because they are opposite of that angle, right? And angles because they are angles. Alright. So we describe or we state this property by saying that the sum of the interior opposite angles is the exterior angle. And exterior angles refers to that angle. So there are quite a few ideas and terms and property that we are looking at here. So it might take some practice to get used to. So let's pick up an example. Okay, let's do that. Suppose I have this question in the exam. Okay, this question says that that angle is 70 degrees, that angle is 60 degrees, and the question is, what is y? So now that we have learned about these interior and exterior angles and their properties, we know how to do this. Y is the exterior angle. The 70 and the 60 degree, these two angles are both opposite to the y. Okay, and they are on the interior of the triangle. So therefore, the sum of 70 and 60 must be equal to y. So y must be equal to 70 degrees plus 60 degrees. The answer is 130 degrees. So that's the answer. So that is the kind of question we might get, and this is how we could use the property. So if you do need to give a reason, and often when you do working in your exam paper or test paper, it's always better to give the reason. So in this case, the reason is a bit long to say. Basically, you just have to say the sum of interior opposite angles is the exterior angle. Let me write that down just to be quite clear. So if I were to give the reason for this, I would say sum of interior opposite angles is exterior angle. Alright? Okay, now next we are going to look at a way of writing notations for a triangle. That means about labeling the sides and angles in a triangle. So if I have a triangle, now very often you will see labels for the corner like A, B and C, usually in capital letters. So this is what you often see in a test or exam questions. Okay, they will label the figure ABC and start asking you find A or find angle B. Or they would also say, let's see. Just for example, let me wait. That's the angle A. Let me just call that angle X for now. Okay, so quite often to refer to this angle X, there are many ways to do it. One way is just to put a little X there and that's the angle X. Now another way is to say that this angle X is referred to it as the angle which is between the sides AC and the side AB. Okay, and the notation for that is you use a little angle kind of symbol there, and it's called the angle CAB. Okay, so you see this notation quite often. That's the angle notation. Some people might put a cross there, but you get the idea. Now another way that is also quite common of naming this angle is just to call it A. Call it by the name of the corner. So if I say angle A, that's quite obvious which angle I'm talking about. Is angle A. So that's angle B, that's angle C. Okay, so this is just a common way of writing the names of the angle. So that's the angle. Now, and then we might also have to write symbols for the sides of the triangle. So we are basically doing algebra here, because in an exam question we may not always know what the side is and we may have to find it. So we would need some symbols to represent the sides, like X or Y, symbols like that. But in a triangle, if you have labeled the corners by this capital A, capital B and capital C, it is usually convenient to call the side opposite to this corner A, to call the side length little a. So that means that if this corner is capital A, then it is convenient if I call the length of the side opposite this angle, if we call that length little a. Okay, it is convenient because if we all stick to this notation, then even if I have not labeled that side as little a, the moment you see little a in the textbook or in the exam question, you would know that little a means the side opposite of the corner labeled by capital A. So it is just a common way of doing it. So in a similar way, we would call this side, which is opposite the corner of capital B, we would call this opposite side little b. And we call this side, which is opposite to corner C, we call the length little c. So these are some of the common notations used in triangles. Okay, so that's notation. Now, another property of a triangle that we are now going to look at is quite special. Now, you might have heard of this already. Okay, it is called the Pythagoras theorem. Now, this is a property for right-angled triangles only. So that means that if your triangle has a right angle inside, then you can use this theorem. But if there are no right angles, if they're all acute or obtuse, then you cannot use this theorem. It would not be true. Okay, and the theorem is this. Let me give some names to the sides. So suppose that the length of this side is B, that side is A, and this side is C. So A, B and C are just numbers. Okay, we don't know what exactly they are, but we just let them be A, B and C, like we do in algebra. So Pythagoras theorem says that C squared, let me start with A, that A squared plus B squared is equal to C squared. A squared means that you take the length of side A and you square it. You multiply the number by itself. That's A squared. So B squared means that you square this length. So if you square this side and add them together, the answer must be equal to the square of the longest side. That's Pythagoras theorem. So it's a very useful theorem. Let's just take a quick look at an example to see how to use this theorem. So suppose that I put in some numbers as an example. Suppose that this side is 4 centimeters and that side is 3 centimeters. Okay, and the question is, what is the length of that side? So this could well be an exam question or a test question. Given that the two shorter sides are 3 and 4 centimeters, find the longest side on the right-angled triangle. In order to do this, we need to use Pythagoras theorem, because this theorem is an equation that relates all three sides of the triangle. So let's use this theorem now. Okay, the obvious thing to do would be to substitute 3 and 4 into the formula. So think of the theorem as a formula. So A is 4, so we have 4 squared, B is 3, 3 squared is equal to C squared. And we have to find C. Now if you look at this, you already have an equation, and C is the unknown that we must find. So let's calculate this. 4 squared is 16, 3 squared is 9, C squared, and 16 plus 9 is equal to 25. So therefore, if you know that C squared is 25, you can find C if you take the square root. Okay, C is the square root of C squared. So you need to take the square root of 25 to get the answer. And you often have to use your calculator to find the answer. But in this case, we happen to know that 25 is equal to 5 times 5. Is equal to 5 squared. So therefore, the square root of 25 is just 5. So that's how we can use Pythagoras theorem. Alright, if you know the two sides of a right-angled triangle, this theorem allows you to find the length of the longest side. Okay, we are going to look at one more property. This is the properties for the isosceles triangle, where we have two sides equal. So the first property, we already know. I mentioned just now that these two angles are equal. So let's take a look at an example of how we could use this property. For example, suppose I have a question. In this question, I'm given that this angle is 40 degrees. And the question is to find that angle, find x. So how do I do it? So the first step is to remember that because this is an isosceles triangle, because these two sides are equal, therefore those two angles are equal. So that if that angle is x, this angle must also be x. So I have x there. Alright. So the next thing is to remember that the sum of the angles in a triangle is 180 degrees. That means that if I add 40 to x, I must get 180 degrees. So what I can do is I can write this down. 40 plus x must be 180. So if you do this, you find that you have an equation and you can solve for the x using algebra. Now, but for this simple example, we can also do it more quickly just using arithmetic directly. The way is to just think about it in a simple way, that because when you add all these three angles up, you must get 180 degrees. Now, and if you take away 40 from 180, the answer must be the sum of the remaining two angles. But since we know that the remaining two angles are equal, I just have to divide that by 2 to get the answer. Now, let me say that again. The sum of the three angles is 180. Just going to write this out. The sum of the three angles is 180 degrees. If I minus 40, if I subtract that angle from the total, the answer must be the sum of the remaining angles. Okay, so this must be equal to x plus x. But I know that the two angles are equal. So if I want to get x, if I want to get one angle, I just have to divide that by 2. And that should give me the x. So that's also a simple way to do it without having to think about algebra. A rather more direct way. And the answer is 180 minus 40 is 140. Divided by 2 is 70. That's the answer. Okay, that's property with these two angles. Now let's look at another property. Okay, we have this isosceles triangle with these two sides equal. Now, suppose from the point on top, I draw a line to the opposite side. I draw a perpendicular line to the opposite side. That means a straight line that meets the opposite side at 90 degrees. Okay? So if you're finding the area of a triangle, that could be the base and that could be the height, for example. So if I draw this perpendicular to the base, now one property that comes from this is that these two angles are equal. Now you can sort of understand why, because if you draw this perpendicular to the base, then this vertical line is like a line of symmetry. You see, the left side looks the same as the right side. If you flip this over, it looks the same. So therefore, it is quite reasonable that the two angles are equal. Right? And for the same reason, when this line comes down and meets the base, it divides the base into two parts. And those two parts must be equal. Okay, the reason is again because this side must be symmetrical to that side. So therefore, this length must be equal to that length. So in other words, if you draw a perpendicular to this opposite side from the top corner, this perpendicular would bisect the opposite side, and it would also bisect the angles. Right? Bisect just means cut into two equal halves. So it would divide the opposite side into two equal halves, and it would divide this angle into two equal halves. So that's the next two properties, in fact. One for the angle, one for the base. Okay, so we will stop here for this session. See you next time.